The key to this unit is, first of all, memorizing the list of perfect squares that we provided. Here's the first several. List of perfect cubes, fourths, and fifths. So here's the first few. Now the key to this lesson is understanding this relationship here. So the top part of a fractional exponent is the power, which you can take the power of the number before or after you take the root. And the bottom number, or the bottom piece, is the root. So if that was a 1 over 3, you're taking the cube root. If it's a 1 over 2, you're taking the second root, or square root. So let's do a few examples here. 7th root of 1. So what that's really asking is what times itself 7 times would give you 1. Right? So since 1 to the 7th is 1, if we take the 7th root of each, that gives us this result. So this is saying what times itself 4 times, because of that index, equals 16. Well, 2 times itself 4 times will give you 16. Therefore, since 2 to the 4th is 16, the 4th root of 16 is 2. Pause and think about that for a second if you have to. I'm going to go through these next ones a bit quicker. So, cube root of 27 is 3. You should have that memorized. Now, because the 3 is on bottom here, that is the root we're dealing with. So the cube root of 8, and I'm going to take the cube root of 8 before I square it, because I want to make things smaller before I make them larger. Makes it easier to deal with. So cube root of 8 is 2, 2 squared is 4. Now, writing these in radical form, the exponent only applies to the x in this case, because you do parentheses, or order of operations, you're going to multiply, or raise the exponent before you multiply by the 27. So that's going to be cube root of 27. 27 times cube root of x, rather. Since this whole thing is being raised to the 1/3 power, it applies to both. So writing it like that. Now, we can take the cube root of 27, so we will simplify that and get that result. So writing each x in exponential form. So I'm going to deal with the numbers, and, well, actually, that's like a square root. So the one without an index written is called the square root. So this is the denominator. So 8 over 2 simplifies to 4. Now I apply that 4 to each term there. Get 81x4, just doing my power to a power rule. Here I'm going to deal with the numbers differently than the variables because there's no parentheses underneath there. So cube root of 64 I'm going to take before I square it, because I don't know what 64 squared is anyway. So for the numbers, so cube root of 64 is 4. And then x written in exponential form is going to be like that. The last one here, down here, writing those in exponential form gives me that. Now my exponent rule in this case is when I'm multiplying the same base, I add the exponents. So I'm going to add all of those. 1/4 times plus 1/4 plus 1/4 plus 1/4 is 1. So there's my final answer. Last one in this example. Oh, sorry, should have finished that one. Write that as a 5th root of 32. 5th root of 32 is 2. And then this is the bottom of the fraction because it's the index. This is the power, so that goes on top. Final answer.